negative binomial distribution. So suppose we do repeated trials of an experiment so that each time there are two possible outcomes, success and failure. And the probability of success in each trial is the same, let's say little p, so that's just like the binomial situation. Then the probability that it will take x trials to get k successes is given as f of x equals x minus 1 combination k minus 1 p power k 1 minus p power x minus k. Okay, so x is said to have negative binomial distribution. Okay, so let's see. The probability that a person living in a certain city owns a dog is estimated to be 0.4. So P in this case is 0.4. Okay. Find the probability that the 9th person randomly interviewed in the city is the 4th one to own a dog. So we want the 9th. So it's the same as saying that it takes 9 persons to find 4 dogs. So the 9th, the success is having a dog. So what's the probability that it will take 9 trials to find k successes? So x is 9 and k is 4. 9th person is the 4th one to own a dog. So the probability would be x minus 1 would be 9 minus 1 combination 4 minus 1. 0.4 power k, so 0.4 power 4, and then 1 minus b would be 0.6 power x minus k, so 9 minus 4. Okay, so let's see, 8 combination 3. Times 0.4 power 4. Times 0.6 power 5, I get 0.1115. Okay, let's look at this one. Find the probability that a person flipping coins gets 9th head on the 11th flip, 1st head on the 10th flip. So in part A, 9th head on the 11th flip, so x is 9, x is 11. So it takes, we're talking about taking 11 flips to get 9 heads, so x is 11 and k is 9. It's the number of successes we want on the 11th flip. And P is the probability of getting ahead, which in a fair coin should be 0.5. Because we're calling getting ahead as the successes in this case. So it would be 11 minus 1, 9 minus 1, p power k, so 0.5 power 9, and then 1 minus p is also 0.5 power x minus k, so 11 minus 9. And let's see, 10 combination 8 is the same as 10 combination 2, which is 45 times 0.5 power 11, basically. 0.02 197, so 0.0220, so 0.022. And the probability that a person flipping a coin gets the first head on the 10th flip. So in part B, X is 10 and K is 1. So we have 10 minus 1, combination 1 minus 1, and 0.5 power K, so 0.5 power 1, and then 0.5 power N minus K, 0.5 power X minus K, so 10 minus 1. So basically it's 9 combination 0, which is 1, and then times 0.5 power 10. So 0.5 power 10 is 0.00097, so 0.0010. So 0.001. Okay. So let's look at this number 4 as well. Suppose the probability that any given person will believe a tale about the transgressions of a famous actor is 0.75. What's the probability that the 8th person to hear the tale is the 4th one to believe it? So A, 8th person is the 4th one to believe it. So X is 8, K is 4, and P is 0.75. Because believing a transaction is believing the tale is called, we're calling that as a success. So 8th person is the 4th one to believe. So it'd be 8 minus 1, combination 4 minus 1, and then P power K, so 0.75 power K, and then 1 minus P is 0.25. Power 8 minus K, X minus K, so 8 minus 4. So 7 combination 3 basically times 0.75 power 4 times 0.25 power 4, 0.0433. And the next part is similar.